Students, my biggest apologies. I have to do part 2 of the lesson. I realized in hindsight I didn't cover everything I was supposed to today, so I'm going to go fast. Let's take a look at a couple more things. These are important for the main idea for people that want to do very good in mathematics. These are special cases. We talked about special cases in class today with parallel lines and the same line. Parallel lines. So let's take a look to see what would happen in substitution with parallel lines or the same line. If you had y equals 3x plus 5 and y equals 3x plus 4, same slope, different y-intercept, they are parallel, there is no solution, but how does the algebra work out? That's the question. Well, if we set these two equations equal to each other, because y is equal to y, so 3x plus 5 is equal to 3x plus 4. And then we start solving. Maybe subtract 5 from both sides. So you get 3x equals 3x minus 1. Subtract 3x from both sides. And when you do this, something interesting happens. All of the variables go away, and you get 0 equals 1. What does that mean? It's confusing, so let's take a look over at the same line situation and see what happens there, and then we'll make some conclusions. Same scenario, it's y equals y, and the two equations are the same line, and if we set 3x plus 5 equal to 3x plus 5, and then first step, let's just subtract that 3x from both sides, and you get 5 equals 5. Okay. In a problem like this, if you're unaware if the two lines are parallel or the same line, but you're working through the math with the algebra, there's going to become a point when all of the variables cancel out. So in this case, all of the x's cancel out and we're left with 0 equals 1, which happens to be a false statement. Over here, when we set the two equations equal to each other, we got 5 equals 5, which is actually a true statement. What this means is that because this is false, that means that there are no points in the universe that you could plug into this equation and get a solution. It's just physically impossible, and this false statement is what tells that to you. So if you get to a point in your work that you get 0 equals 1, it's a false statement. That means that the lines are parallel, thus no solution. On the other side, if all the variables cancel out for some weird reason and you end up with a true statement, that actually means that your two equations were identical to each other. They were the exact same equation. So I'd put here that the lines are identical. They're the same. A couple different ways you could word it, I guess, but I like the words identical. And then if the two lines are identical, that means that there's an infinite number of solutions. So those are the two special case scenarios that I wanted you to be aware about. What happens with parallel lines and the same line. That will happen in your practice tomorrow. Story problems are also going to start making an appearance. Let's do this story problem right here. Rabbit, he was a student from last year in my Algebra 2 class. I miss you, Rabbit. Rabbit had 2 hot dogs and 3 hamburgers, and he spent $13, and he stuffed his face. Ben, he bought 4 hot dogs and 5 hamburgers. He spent $23 and had Rabbit stuff his face again. I guess Rabbit was pretty hungry. How much do hot dogs and hamburgers cost? Well, I'm going to show you the entire problem right here. But the hard part for most people is writing the equation. In a story problem, the first thing you have to do is you have to identify your variables. If you don't identify your variables, we don't know what x is, we don't know what y is. Whoa, I didn't even use a variable of y. You can use any variable you want. X is traditional. I wonder why I always choose the variable m. No, not sure. I just do. Anyway, You got to identify those variables. We're looking for how much hot dogs and hamburgers cost, so I had X be the cost of hot dogs and M be the cost of hamburgers. And if X is the cost of hamburgers and you go 2 times the cost of hamburgers, that'll tell you how much money you spent on, not hamburgers, on hot dogs. That'll tell you how much money you spent on hot dogs. And if you ate 3 hamburgers and you spent 3 times the price of those hamburgers, it would be 3M. And the cost of hot dogs plus the cost of hamburgers, that worked out to be $13. Second equation, 4 times the cost of hot dogs, 5 times the cost of hamburgers, that'd give you a price of $23. All right, now we get into solving these equations. And the problem with this one was substitution. I actually normally wouldn't use substitution to solve it, but if you had to use substitution, this would be the technique. When I look through these 2 equations and I look at the 2 in front of this x, the 3 in front of this m, the 4 in front of this x, and the 5 in front of that m, I like the idea most of using this first equation and solving for x, because in that case I only have to divide by 2, which will give me easier to work with decimals. So I took this equation, subtracted 3m from both sides, divided by 2, and I got x equals 6.5 minus 1.5m, at which point that allowed me to plug into the second equation. That gave me an equation with nothing but m's. I solved out that equation for m. For m I got 3, losing some of this. There we go. I then picked any equation. I picked my x equals equation. I plugged the 3 in for m into that equation. 6.5 minus 1.5 times 3. That's 6.5 minus 4.5, which gave me 2. And then, at the end, you have to answer the question. This is a story problem. So at the end of the day, x was 2, so hot dogs were $2, hamburgers were $3. Everybody, I'm really sorry about the second quickie lesson. I hope you have a great night, and I'll see you tomorrow. Bye-bye.